Okay, while Wojciech is preparing, please give him a warm applause. And Wojciech is a radio amateur since 2016, and he's a recipient of the ARRL Technical Innovation Award 2021. And he's an enthusiast for open source and hardware, and he's the founder and team lead of the M17 team. And Niccolò is also here? No? Well, that's his fellow developer, Niccolò Izzo, India Uniform 2 Kilo India November, is pursuing a Ph.D. degree in information technology at the Politecnico di Milano in Italy. And among his research interests are security in traditional and emergent memory subsystems and microarchitectural side channel attacks. And in 2020, he co-founded the OpenRTX project. That's an open source firmware for digital radios. So I hope we're almost ready to start. And I'll leave the stage to Wojciech and withdraw to my table.
Hello everyone, my name is Wojciech Kaczmarski and my call sign is Sierra Papa 5 Whiskey Whiskey Papa. And I would like to present my project, which is called M17, and let's talk about it a little bit. So let's start with the basics. What is M17? So M17 is a digital protocol that was designed by hands, for hands, so we are not constrained by any manufacturer. And M17 is using the free Codec 2 voice coder at 2 different rates, but I'm going to address that later. So as I said, it was designed by hands and for hands. We don't have any company or an organization or anything like that, any entity. The M17 was a response to growing digital mode community, mainly focused on DMR, D-Star, NXDN, and other stuff like that. So there is a lot of fragmentation already, so we might be thinking, what's the reason of creating another digital mode? So the reason was that all the modes that exist right now, that are not, of course, M17, are based on MB voice coders or similar MB plus and MB2 plus or whatever. And they are all patented and encumbered. So if you want to use a radio with DMR, for example, there is a great chance that there is a chip inside that is made by DVSI or something similar that does the MB coding. So we didn't like that, and we decided to get rid of MB and use Codec 2 instead. And the idea was not just to take the existing protocol like DMR or NXDN, but to create something different that is just based on Codec 2 and it's not based on anything else, so from the scratch, the protocol. And this is like bringing back the experimentation back to our hands. So when you get a radio, like, for example, on Taitira MD380, you can just buy it, but you don't exactly know how it works. So this is wrong. I think we should have big influence on what's going on in our radios and have some like hands-on experience on that. So we have to know what's the encoding type, how is the voice encoded, what is the error correction control, etc. So M17 is a response to that. And why we have created it? Mainly, it was created for fun, and it started as a weekend project back in 2019. And it's not made for profit. We are not an organization, as I said, and we are not getting any money for our work. That is not grant money, but I'm going to address that in a second. So, as I said, this is based on Codec 2, which was created back in 2010 by David Rowe VK5 DGR. And this is the same codec that is used in 3DV. So it's probably familiar to some of you already. The development of the protocol is driven by a big community of ham radio operators. So we are not, as I said, we are not depending on Retevis or Titera or Baofeng or Motorola or any other manufacturer. This is our own stuff, and we say what we want and how we want it. Then, this is also an important part that the M17 protocol is pretty much extensible. So even if you can't send a short message, a short text message using our protocol, you can say that, okay, I can't send an SMS, so let's add that functionality to the protocol, and we are going to do it. Because there is a need, so there is a response for that need. So it is extensible, and use cases can be added over time. The origins of the protocol, it all started back in 2019 in Warsaw, in amateur radio club SP5KAB. I'm a member of that club. And the club itself has a long history dating back maybe not even to 50s, but even to 40s. So it's a really old club with really long traditions. And this is a picture of the Plac Bawiciela place in Warsaw, and this is the central part of the city. And just by the church, there is a building where the club is located. Oh, and by the way, the name M17 comes after the street address of that club, which is Mokotowska Strasse 17. So that's the name M17. In 2019, it was just a handful of us, like maybe 4 or 5, interested in digital modes like Tetra, DMR, NXDN, pretty much it. So we decided to start something new, something that's totally different, and something that we have control over, because you don't have any control of DMR and NXDN and any other, especially Tetra, any other mode. And after just a few years, we have grown up to a big international community of amateur radio operators, which are located in pretty much any continent, excluding the Antarctic, probably. And we have also 130 reflectors worldwide, also in pretty much every continent. So it all started as a weekend project of me and a few other friends from the ARC that I mentioned before. And it all started with a simple board, which is RFM26W, which uses a C-Labs SI4463 chip. And it does 4FSK in packet mode. And it probably can be hacked to use to do streaming mode also, but I think I used packet mode back then. And in 2019, M17 looked totally different than it does now. This is the first setup that I had. It's just a Nucleo 767 board with a short breadboard, a microphone speaker. It doesn't yet have the RF module connected to it. It's hidden in the upper right corner in that zip bag. So that's the first test of Codec 2 on STM32. Then, after I had this, I decided to design and actually manufacture a few TR9 handhelds that were able to transmit and receive M17. Of course, that M17 was a little bit different than it is now. But it looked like it worked. I was able to transmit my voice using that protocol. It wasn't really efficient. It used probably 25 kilohertz wide channels, and it used 2 time slots, which is no longer in use because M17 is FDMA right now, totally. And after I have took the photo, this one, on Reddit back in 2019, a lot of people contacted me asking about details of how it works, what's M17, how can we use it, how can we recreate that handheld, what can be done with it, how can they help, and so on. After Dan Romanchik's blog entry containing exactly this photo. This is a historic photo. Then, forward to 2020, a lot of media coverage, including Twitter, Reddit, and Hackaday probably, Hackster.io, and websites like that. Then we refined the protocol to switch from TDMA to FDMA. Then the bandwidth was reduced from 25 kilohertz to 9 kilohertz, and it stays the same up to today. And then OpenRTX project started in 2020, but it didn't yet contain M17, so it was in its early infancy. Then DAG88DP added M17 capability to DroidStar. That's an Android application that you can download right now and use it, also with M17. Then Tom and NCVTAE created a tool called mVoice, which you can run under Linux and Windows. And you can change your computer to M17, let's say, not a reflector, but a gateway. So you can connect a microphone, or if you have a built-in microphone, you can use it. And you can connect to any reflector you want and transmit and receive M17 over the internet using mVoice. Then Roberix WX90 wrote a great piece of C++ code that does M17 baseband to audio conversion and vice versa. And that tool is actually the backbone of M17 as we know it right now. So it's, the code is acting as a reference for any other implementations. Then, 2021, we have received a grant from ARDC, a substantial grant, which helped us to develop better protocol, because the protocol itself evolves over time, so it's not fixed. But the changes right now are pretty much cosmetic. Then later that year, I have won ARRL Technical Innovation Prize for work on M17. Then after I have won it, there was a lot of Twitter entries and Reddit entries on M17. And then MMDVM and OpenWebRX started to support M17. So actually you can download OpenWebRX, install it, connect an SDR to a computer, and you can have M17 demodulation using OpenWebRX. Then, about probably in April, we had first QO100 satellite tests. So we were able to transmit, and actually I did that. I was able to transmit M17 baseband using the wideband transponder and receive the signal back, but unfortunately I wasn't being able to decode the voice back because the signal was very wobbly. This is me and my QO100 setup back in Warsaw. And you are pretty much, I'm pretty sure you are familiar with the green spectrum plot from the Goonhilly station in the UK. And at the bottom, you see the spectrum of M17 that is moving left and right in frequency. And I wasn't able to decode the voice back then. Then, this year. G4GUO, Charles, managed to actually transmit M17 signal using his QO100 setup, and he was able to also decode it. So he was the first one to use M17 over the wideband transponder for TX and RX. Then we had some specification improvements by JKA1PQK, who's based in the United States. Most of us, of the M7 team, are located in US and Europe. We also have some contributors in Southern Africa, Australia, and Southern America. Then we don't have it yet, but we are planning to release a package of out of 3 GNU radio blocks, and Dave N1 AI, located in the United States, is working on that as we speak, probably. Then we've got module 17, and I'm an exhibitor today, and it was yesterday. And we've got module 17's modem boards that you can just see how they look like. You can play with them and visit our booth. It's in Hall A1, 330 is the number of the stand. So you can come by and check how actually module 17s work. And module 17 was designed by DB9MAT with a little bit of my help. I did some parts of the schematic, and DB9MAT did the PCB design. And this is all open source, so this is available on GitHub. You can do a fork and improve it if you like. You can do any improvements and changes. And this is everything that is M17 is free to use and totally open source. Then OpenRTX started to support M17 just like a month ago or something. So actually you can buy an MD380 radio or MDUV380, which is a dual band handheld transceiver. So you can buy the radio, do a small modification to it, reflash it with OpenRTX firmware, and you get M17 compatible handheld that is capable of transmission and reception of the signal right now. So this is the speaker mic board that is also the modem board. So it's called Module 17, designed by DB9MAT and me. So we are trying to reduce the form factor of it to be smaller, because right now it's like 12 by 12 centimeters big. So we want it to get it smaller so it fits your hand, and you can connect it to a radio and receive and transmit M17 using pretty much any radio that is 9600 bits per second capable. Steve KC1 AWV and Ed N2XDD are our team members that are based in United States and exactly the Long Island, close to New York, and Steve is located close to Boston, so those guys are pretty close to each other. And they gave a really huge number of interviews for different bloggers, different YouTubers. So if you search for M17 on YouTube, there is a big chance that you're going to get a long list of interviews with those guys. Then we also attended pretty much a lot the major ham festivals in the US, and right now we are here in Friedrichshafen, which is great, and I'm really honored to be here. This was my test setup back in Warsaw, where I transmitted M17 using an USRP B210 SDR, and received the signal with an FTM 6000 that we also happen to have at the booth. And the resulting eye diagram is in the lower left corner, so it looks nice. And there is no modification to the radio needed to get that eye diagram. Then, about half a year ago, I tried to get a power amplifier that would be able to transmit 5 different M17 carriers independent from each other using GNU Radio, which is a great piece of software. And I was able to transmit 5 different carriers using M17, and I was able to decode every single one of them using SDR'22, which is also a great piece of software, and I can recommend it. Now, we've got over 130 reflectors worldwide, and that number was a week ago, so now we can have probably 140 even. And we've got a lot of Twitter followers, and that number is from a week ago, and I believe it's more than that right now. We've got a lot of Discord chat users, over 600 people who are interested in M17 and talk with us pretty much every day. So you can reach out to us using Discord. And we've got M17 Wikipedia article in 5 languages. Now let's switch to technicalities. M17 uses 4FSK modulation, and the channel width is actually 9 kilohertz, but we are using standard 12.5 channels that are also separated by 12.5 kilohertz. And the gross throughput of the M17 is 9600 bits per second. That means, of course, 4800 symbols per second. We also support stream mode and the packet mode. The stream mode is used mainly to transmit voice, and the packet mode can be used to transmit geographic location and some telemetry data. We've got pretty much hard error control coding because there is a lot of overhead for the error coding, because the net gross throughput is 3200 bits per second. So that's the Codec to rate, the full rate of it. We also support Codec 2 in its half rate, 1600 bits per second. And while having the half rate, the rest of the frame can be used to transmit other data along voice at the same time. I think one of the best parts of M17 is that you don't need to register anywhere. You can just use your call sign, punch it into a radio, and just start using M17. So no registration necessary, and we don't have to run any database of all of the users. Then in DMR, you've got something that is the color code, which allows to use one frequency for more than one party. So there are no collisions, and this is similar to CTCSS known from the analog FM. In M17, we've got CAN, which is channel access number, and we've got 16 of them. And also, we support strong encryption, which is turned off by default, but you can still use it, of course, if it is legal to do so. So there is no necessity of using it. So you can use it only if you can. And this is it. And I'm open for questions, and thank you for listening.
Yeah, thank you very much for this nice and interesting talk. I have one question just to open the questionnaire from the audience. The question is, we had a talk some years ago here in the SDRA about Codec 2, and you know Dave, who invented the SM2000. Can you please give me an impression, how would you classify your project in comparison to the SM2000? You know the SM2000?
Not really, but I'm aware that Codec 2 is used in 3DV. So this is the same codec that is used in 3DV.
Are they harmonized to each other, or
No, not really.
compatible?
No, not really. 3DV uses OFDM, and we are using 4FSK. And the main difference between 3DV and M17 is that 3DV is used mostly for HF bands, and M17 is a better fit for VHF and up.
Well, the SM2000 is a VHF transceiver, which he invented maybe 4 or 5 years ago. I don't remember exactly. It is pronounced on his website.
I'm not sure. I'm in contact with David Rowe, but we mostly exchange technical data about Codec 2 and its internals. So I'm not really, I mean, I am interested in other uses of Codec 2, but I'm mostly focused on M17 only. It takes a lot of time.
Of course. Well, the project is growing a lot, and you showed very impressive how many people are working on this project and giving a strong growth of it. But just it is for me the question: what is how to harmonize these projects? Well, the SM2000 is an open VHF transceiver. The plans are already open. It can be bought from a Chinese supplier, to my knowledge, just the question is, how are you looking on this old project, and how do you take up the users from that to the M17 project? This is my question.
So actually, we don't want to steal anyone's users, and especially users that already use Codec 2. So I don't really know how to answer that question. And if you think about the hardware that we use, we only have probably module 17s to transmit and receive M17. So this is the only hardware that can be bought and used for M17 straight away.
Okay, well, I don't want to make this discussion too wide,
of course.
So we should end at this part. Questions from the audience?
Yes, in UQ100 reception, there was actually a frequency shift about twice the bandwidth of the signal. Is your receiver able to handle that, or is that solved in a different layer?
No, back then we were not able to receive the signal because it wobbled a lot, and we don't really have a solution to that. So, in fact, M17 is terrestrial mode. So this was just a test to see if we can demodulate M17 using QO100, where the SNR is very low. So back then it didn't work, but this year it did. So I think you have to ask Charles G4GUO about the details. And I think the main reason for the wobble was that I was using a cheap converter without any stabilization. And I hope this answers your question.
Yeah, hello. For M17 protocol specification, I'm just wondering what will happen if you improve it so it will break the old specification and you have so many platforms out supporting it. How fixed is it? How are the improvements going forward? How do you avoid that if you want to have a great idea and want to move on with the protocol without that you need to make a hard cut for old platforms which are not supporting a newer generation of the protocol?
Okay, so the answer to that question is that if you want to add something to the specification, we can do it. If you want to change something like, let's say, the error coding, we are using convolution coding in M17. So if you said that, okay, the constraint is 5, let's extend it to 7. We can have it, but probably that would cost a lot of coding work to make MMDVM compatible, to make OpenRTX compatible. So probably we are not going to do it, even if it's slightly better. It would have to be a lot better to make the change. And how do we keep in sync? Well, the changes to the specification are pretty much cosmetic, so we are not changing the core stuff that is already inside. So we are not changing the error coding, the bit location of everything that we send in a frame. So that stays the same.
What about scaling? If I have a channel which is capable of 19,200 bits, for example?
So probably you could use higher symbol rate. And in fact, you could use M17 using higher symbol rate and use it with TDMA. So you could actually modulate faster, get some additional time slot, and just interleave 2 different M17.
So instead of your 5 signals, you can have 1 signal with higher speed, for example?
That's correct. And it will take just a little bit more of bandwidth, of course, right? But yes, it is doable.
Okay, thank you.
Thank you.
There is a question in the YouTube chat. Where is it? Markus Müller is asking, what SNR is an AWGN channel? In an AWGN channel do you need for M17? At an acceptable bit error rate, I don't know what BR would be tolerable for Codec 2, question mark.
I don't actually know the answer to that question because we work mainly in a terrestrial, let's say, environment. So no one tested this, actually. And in QO100, we had SNR of about 10, I believe. And it started to work. And the speech was intelligible. So I hope this answers the question.
Yeah, well, I appreciate it a lot that you came up with a protocol specification. I just don't get it completely yet because the specifications behind, say, DMR radio are open as well. I can get it. I even can get it without of cost, as I understand it. Is it the control that we have over the M17 specifications? And this leads over to the question, who has the control over M17? How do you manage this?
So we all actually have the control of the protocol because everyone is welcome to contact us and propose any change that they think is necessary or would be better to have it. And there was an idea to use DMR with Codec 2 because DMR is vocoder agnostic, so it doesn't care if the vocoder is Codec 2 or MB or anything else, which is at most that bit rate. So the problem with DMR running Codec 2 is that first, no one did it because there is a good reason not to do it, because it would just cause a fragmentation within the DMR itself. So it's not like adding another mode, it's like fragmenting existing mode. So no one did it, I believe. That's the reason.
Okay, I have to look on the timetable, and we are just 10 minutes now in the pause, and we have the next date at 12 o'clock, so in 5 minutes. Thank you for the discussion, and thank you for all these presentations up to now. And hopefully, and you have seen, there's a lot of time to discuss about who decide what it is coming into the specifications of the M17. And I think M17 will have a big discussion in the next year.
Sure.
So,
and if anyone has any questions, we are at the booth 330. So just come by and say hi.
In the hall 1.
Yes.
Yeah. Okay. So. All these peoples who are asking and discussing here, thank you very much for that.